Hello my dear students, you are welcome. This video is about acids. What is meant by an acid? Acids are substances that produce hydrogen ions, H plus or protons when dissolved in water. Like when we pump hydrogen chloride gas in a beaker containing water, what would happen to HCl gas? HCl gas dissociates and the bond between hydrogen and chloride is broken, and the HCl molecules dissociates into hydrogen ions H plus and Cl minus chloride ions. Now the beaker containing hydrochloric acid. So hydrochloric acid is a strong acid. It dissociates completely. It is ionized completely into chloride ions and protons. So we can consider acids as proton donors. Okay? Acids are proton donors. What is the general formula of an acid? General formula of an acid is HA, where H refers to the hydrogen ion, H plus ions, is the hydrogen ion. A minus is the negative ion, This ionization in water, when we dissolve or add concentrated acid into water, what would happen? It dissociates with different degrees. So for mineral acid like hydrochloric acid, the chemical formula HCl. Its positive ion protons H plus, while its a negative ion or anion chloride ion Cl minus. For sulfuric acid, H is the proton of the acid. This acid can dissociate and each molecule gives two protons. When dissociated, one molecule of sulfuric acid, it releases two protons in solution and one anion called sulfate ion, SO4 minus 2. What about nitric acid? Nitric acid dissociates into nitrate and protons. So all acids must release protons in solution. Must, as we define acids as proton donors, so they release protons in solution. Now, for which ions are responsible for which ions are responsible for making a solution acidic? Sure, hydrogen ions. Hydrogen ions are responsible for acidity of solution. Look at this figure. Here pH scale. This pH scale where hydrogen ions accumulate in certain solution. This means more acidic for pH 0, 1, 2, 3. This highly acidic solutions, while as we go from left to right, what about hydrogen ion concentration on the scale? It decreases gradually, so the acidic medium decreases in strength. So name 3 natural acids found in foods. Organic acid found in foods, naturally occurring in foods, like what? Like citric acid found in oranges and lemons. Ethanoic acid found in vinegar. Methanoic acid found in nettles and ants, and sting containing methanoic acid. Also this plant containing the same acid, methanoic acid. Also lactic acid in yogurt. List 3 common mineral laboratory acids. Like what? Like common laboratory acids like HCl. They are considered mineral acids. List 3 common mineral laboratory acids. Like what? They are common and you can see them in shelf of chemical school lab. Okay, they are common. They are called mineral acids, like hydrochloric acid HCl, like sulfuric acid H2SO4, like nitric acid HNO3. All of these acids are found in lab, commonly used in our experiments. Okay, what would you do if you find an unlabeled chemical in the school laboratory? It is a big problem to find unlabeled chemical in the school laboratory. Firstly, don't touch or use it. Immediately inform your teacher or lab technician. Never taste, smell, or guess what it is. Okay? Describe how you would safely carry out a sample test to find whether it contains an acid, an alkali, or distilled water. Say this unlabeled 3 bottles, okay, containing one of them containing an acid, second one alkali, third one of them containing distilled water. How you can find out whether it contains these chemicals? Look, firstly, we use certain known chemical called indicator. What is meant by an indicator? Indicator is chemical substance that changes color to show whether a solution is acidic, alkaline, or neutral. Okay, like what? Like litmus paper. If we immerse litmus paper in a beaker containing solution and the blue litmus paper change or turn color into red, this indicates the solution is acidic. If we immerse second litmus paper with red color, when it turns into blue, this indicates the solution is basic or alkaline solution. Second indicator, like thymolphenol, it has certain color, okay, colorless in acidic and neutral medium, while it is blue in basic or alkaline medium. Okay, so we can depend on thymolphenol to detect whether the substance is basic or either acid or neutral by its color change. What about methyl orange? Third indicator in this slide, methyl orange. Methyl orange has red color in acidic medium, orange and neutral medium like distilled water, okay, and for base or alkali it turns into yellow. This for methyl orange. Okay, so for summary for this slide, compare the color change for methyl orange, litmus, thymolphenol in acidic and alkaline solutions. Methyl orange is red where in acidic medium, while it turns yellow in basic or alkaline solution. For litmus, it is red also, but turns blue in alkaline solution. For thymolphenol, it is colorless in acidic medium and turns blue in alkaline solution. Okay. What is meant by pH? pH means the concentration. It is a term express the concentration of hydrogen ions H+. Okay, where for basic solution, a little hydrogen ions present in beaker containing certain solution, little amount or little concentration of hydrogen ions. For neutral, equal amount, equal number of H+ and OH-, while for acidic medium, more protons released, okay, more than hydroxyl ions. The pH scale range from 0 up to 14. This indicates what? Values less than 7, it means the solution is acidic, where its interpretation means ion concentration of protons is more. Okay, it has high concentration of protons, while if the pH value equals 7, it's neutral like distilled water or pure water, where equal concentration of protons and hydroxyl ions. Look at the figure. The beaker contains 5 ions of positive protons and 5 hydroxyl ions of negative charge. 5 OH minus, 5 H plus. If the beaker containing a solution with pH value greater than 7, it means what? It means it's alkaline solution, and it contains high concentration of OH minus. Okay, OH minus. Look at the scale. Here, the scale from 0 up to 14. From 0 up to 6.99, it means acidic solutions. For 7, exactly 7, it's neutral. While from 7.1 up to 14, it means alkaline solutions. Okay? On the pH scale, look at pHs 0, 1, 2, and 3. These pHs represent strong acids, while from 4, 5, and 6 up to 6.99, okay, represent weak acids. For alkalis, divided into weak alkalis starting from 7.1 up to 10, okay, while 11, 12, 13, 14, the last 4 pHs represent what? Represent strong alkalis like KOH, like potassium hydroxide, for example. Okay, what is meant by universal indicator and how is it used? Universal indicator, it is mixture of indicators, group of dyes, group of chemicals showing range of colors. Okay, how is it used? It is used for measurement of pH, estimate measurements. Okay, place where we place drop of test solution, unknown solution on universal indicator paper. Okay, and then match the color against the color of the paper against the pH color chart like this. Look here at this universal this universal paper, okay, dipped in solution containing certain chemical, and the color change into blue. We match this paper with the color chart provided with the kit or the container of this type of universal indicator. Okay, what is a pH meter and what is its advantage over using universal indicator? A pH meter is an electronic device like this one. Okay, it is used to measure the exact pH of solution like Coca-Cola, for example. Okay, exact pH, it is numerical. Its advantage over universal indicator, it gives a precise numerical value. Okay, precise numerical value like in this figure 3.12, pH 3.12 for 2 decimal points, while the universal indicator only gives an approximate pH based on color change. Okay, as we check the pH by universal indicator depending on its color, so it is subjective. It may differ from one person to another. Okay, its value or estimate value may differ from one person to another, while pH meter it gives exact and precise value for pH. Okay, now for practical work, we can examine or compare pH of household products like soap, like baking powder, vinegar, lemon juice, washing powder. We make solutions of these chemicals, of these products. Okay, solutions. Then after making these solutions and dipping pH electrode, pH meter electrode inside each solution okay, individually, we can read and record the reading from the pH meter. It's okay. What is the optional setup to observe pH changes over time? Here we can make advantage or make improvement of the apparatus used, like what? Like this device. This device, the same pH meter, but connected with certain device, electronic computerized device called data logger. Okay, we can connect it to show changes over time. Say when we add two chemicals A and B together in certain beaker, and certain chemical reaction takes a time to be completed, during which certain pH change or pH changes over time. How we can detect this change over time? By using pH sensor connected to data logger and the computer to monitor changes when acid is added to an alkali or two chemicals are added together. Okay. What is meant by the strength of an acid, and how can you differentiate between strong and weak acid practically? A strong acid fully ionizes, is fully ionized, while weak acid only partially ionized. Okay, look at this experiments, how we can differentiate between strong and weak acid. Strong acid by measuring pHs for both. Strong acid like pH must be lower than the pH of weak acid. Here strong acid is pH 3, while weak acid for pH more than 3. Here in this figure equals 6. Second experiment, to differentiate between strong and weak acid, we can deal or react each acid with carbonates or reactive metal. The beaker or the reaction that releases more bubbles, it represents strong acid. Okay, the reaction that releases more heat evolved, for example, okay, this also is strong acid, while the reverse for weak acid. Weak acid with carbonates give or release effervescence of gas, carbon dioxide gas, less than strong acid. Also weak acid reacts with reactive metal less vigorously, with less strength. Okay. Third experiment, this by detection of electric conductivity test. Okay, here in series connection for weak acid on the right and strong acid on the left, both on the same electric circuit. Look at the bulb for each. The bulb for strong acid illuminate strongly, okay, with high conductivity, where strong acid dissociates completely into ions. As more ions present, so more electricity passing through. Okay, while for weak acid, less ionization or no ionization means no lighting or little or low light intensity released from bulb. Okay. Strong acid dissociation makes 100% ions completely ionized. If you are given strong acid, look, say 100 molecule of HA, it's a symbol, okay, general symbol HA for strong acid. This completely dissociates into protons, 100 protons and 100 anion with negative charge A minus. If you are given 100 molecules here, 100 molecules from HA, it releases 100 protons that combine with water to give something called hydronium ion, H3O plus hydronium ion. Okay, 100 here and 100 here. Okay, So this represented by complete dissociation. In one direction, this dissociation, in forward direction only. HA in aqueous solution plus water, okay, releases protons combined with water to give hydronium ions and A minus. Look, strong acid like what? What is meant by strong acid? Strong acids means acid transfers all of its protons to water. All. Completely ionized or dissociates. Third criteria, strong electrolyte. Strong electrolytes means complete ionization and passing electricity easily, as we saw. Okay? Like what? Like all mineral acids, they are strong with different degrees: hydrochloric acid, nitric acids, and sulfuric acid. What about weak acid dissociation? Weak acid dissociation only partially ionizes. Here, if you are given 100 molecule of HA as very weak acid, like ethanoic acid, like vinegar, very little dissociation takes place, so little amount of the acid dissociates. Only this part, look at this part, this only dissociates into two types of ions. Okay, H plus, okay, that combine with water to form hydronium ion like H3O positive and A minus. Okay, little molecules ionized. Look, HA plus H2O, here reversible reaction means the hydronium ion after its formation, it can dissociate on the opposite side to give proton again to combine with A minus to give the acid. Okay, it's reversible. It's a reversible reaction. Weak acid, like what? All acids that transfer only fraction of its protons to water, they are considered weak acids. Only fraction of its protons to water. Partially ionized, weak electrolyte, passing electricity or doesn't pass electricity at all. Okay, that's weak acids. Like what? Like organic acids found in tissues, found in cells, like acetic acid or vinegar. Okay, or ethanoic acid, lactic acid in yogurt, for example. This represent weak acids. Now with physical properties of acids. They taste sour taste. They have sour taste. Look, lemon, it has sour taste. Corrode metals, it has corrosive action on metals. It can corrode metals. Okay, if we left this ring of metal or iron inside beaker containing sulfuric acid, it starts erosion. Okay, erosion or corrosion. It has corrosive effect. They are good electrolytes, passing electricity with different degrees according to their strength. Okay, their pH is less than 7. Turns damp blue litmus paper to red, like in this figure. Blue litmus paper turns red. This indicates acid. What about chemical properties of acids? First type of reactions of acids reacts with metals to form salt plus hydrogen gas. Letter B reacts with metal oxides to form salt plus water. Reacts with alkali to form salt plus water. This is called neutralization reaction between acid and an alkali. Okay, so salt and water in letter B and letter C. Okay, for letter D, salt plus water in addition to carbon dioxide release. When acids react with carbonates, salt of carbonates or salt of bicarbonates or hydrogen carbonates, all of this when react with acid, they releases carbon dioxide gas. Step by step. Letter E. React with metals to form salt plus hydrogen. Like when we react hydrochloric acid with magnesium, the salt formed is called magnesium chloride, MgCl2. Sulfuric acid and zinc, the salt formed called zinc sulfate, ZnSO4. Nitric acid and lithium, the salt called lithium nitrate, LiNO3. Okay, step by step, look at this word equation. Magnesium plus hydrochloric acid reacts to give magnesium chloride. The salt of hydrochloric acid is called chloride. The salt of sulfuric acid is called sulfate. The salt of nitric acid is called nitrate. Okay, and hydrogen gas is released. This balanced chemical equation, magnesium Mg, solid form, plus 2 HCl, 2 moles of HCl react with 1 mole of magnesium, okay, to give 1 mole of magnesium chloride, MgCl2, in aqueous solution. It means ionized into Mg plus 2 and Cl minus 1. Okay, and hydrogen gas is released. For second reaction, zinc plus sulfuric acid reacts to give zinc sulfate plus hydrogen. Symbolic equation, zinc plus H2SO4 reacts to give zinc sulfate, ZnSO4 in aqueous form, plus H2 gas. Last reaction for lithium and nitric acid. Lithium plus nitric acid reacts to give lithium nitrate plus hydrogen gas. Okay, LiNO3 plus H2 gas. Practical work. Reaction of magnesium with hydrochloric acid. Add magnesium to dilute hydrochloric acid. Collect hydrogen gas over water or over solution. Look at this test. Here, test tube containing HCl, dilute HCl, okay, and strip or piece of magnesium metal placed in HCl. Immediately, it releases bubbles of gas. This gas kept inside the test tube by closing the test tube hole or opening by your finger or by bong. Okay, so the gas is collected over the solution. When we check this gas by lighted splint, it forms pop sound. It burns hydrogen gas, characterized by burns by pop sound. Okay, pop sound. This confirms this gas is hydrogen. Some hints. Nitric acid only releases hydrogen with metals when very dilute. Okay? Unreactive metals. Not all metals react with acids. Only reactive metals react with acids. Metals that lie above hydrogen or more reactive than hydrogen of water or hydrogen of acid, reactive, they are reactive. They releases gases. They releases hydrogen of the acid. Okay, they are called reactive, like magnesium, zinc. Okay, while unreactive metals, they lie below hydrogen in chemical reactivity series. They do not react with dilute acids like silver, like copper. Okay, copper plus hydrochloric acid, no reaction takes place. No reactions takes place. Letter B. Acid reacts with metal oxides. Metal oxides to form salt and water instead of gas, water now, because this reaction between metal oxides, oxygen is present, okay, in this chemical metal oxides. Like what? General equation, acid plus metal oxide, salt plus water. Here, copper 2 oxide, not copper, copper 2 oxide. How we can obtain copper 2 sulfate? As copper doesn't react with acid, we use copper 2 oxide with sulfuric acid to form copper 2 sulfate. Sulfate is a salt of sulfuric acid, and water. Look at the equation. CuO, copper 2 oxide plus H2SO4 reacts to give copper sulfate in aqueous form, ionized form, plus water. Letter C, reacts with alkali to form salt plus water. Okay, this is called neutralization, reaction between an acid and an alkali, called neutralization. Reaction of acids with metal hydroxide like KOH, NaOH, hydroxide, or aqueous ammonia form salts and water. Look, sodium hydroxide plus nitric acid reacts to give sodium nitrate plus water. Neutralization takes place where neutralization net equation means H plus from acid, from nitric acid, and OH from the hydroxide or alkali to give water. This symbolic or net equation of neutralization. Okay, aqueous ammonia NH3 reacts like metal hydroxide. It gives salt here. This ammonia NH3 in aqueous form plus HCl reacts to give NH4Cl ammonium chloride salt. Okay, last type of reactions, reacts with carbonates to form salt plus carbon dioxide plus water. Carbonate, similarly bicarbonate or hydrogen carbonate, they react with acids to give salt plus carbon dioxide plus water. Three products here, like copper 2 carbonate plus H2SO4 reacts to give copper sulfate plus H2O plus CO2 gas. Okay, hydrogen carbonate reacts similarly with the same manner. Sodium hydrogen carbonate NaHCO3 react with HCl to give NaCl salt, okay, in aqueous solution, plus H2O plus water. Test for carbonate, test for acid, test for CO2. This experiment to show how can we detect the solution is acid by placing carbonate salt. How we can detect the gas is carbon dioxide by reaction between acid and the carbonate. It releases CO2. Look at this test. Here, two test tubes, one containing lime water, clear, fresh prepared lime water. Okay, and this test tube is provided with bung and delivery tube, L-shaped delivery tube, and second test tube containing carbonate salt. Look at the experiment step by step. Okay, fresh prepared lime water, clear, must be clear. Okay, second test tube containing carbonate salt. We add to this carbonate salt the acid. Okay, look what happens. Ever-sense of gas. We now check the gas is carbon dioxide. How come? Look at the bubbles in the second test tube containing clear lime water. What would happen after several minutes or a certain period of time? Look, it turns into cloudy or milky or chalky. Okay, this means carbon dioxide is released. It confirms one of the reactants is acid, the second reactant either carbonate or bicarbonate, I mean hydrogen carbonate. Okay, thank you for watching. See you next time. Have a nice